Good afternoon. Today we are going to talk about day 3 of our evaluating trig functions. This time we're going to look at all the quadrants. We're going to combine all the information together that we have learned about trig and really complete the ultimate question that is most commonly asked of a trigonometry student. Um, we've got the 30, 60, 90 reference triangles. Remember that these triangles are specific based on the angle that is across from the sides. So 30 degrees is always going to be across from a side length of 1, 60 is always going to be across from square root of 3, and 90 will be 2 in a 30, 60, 90 triangle. But because we are manipulating these around the different quadrants today, you want to make sure that you pay attention to the positive negative sides, depending on what quadrant you're in. We're going to do 3 questions today. The first 2 are going to be all in one, and then the third question I'm going to demo is very similar to the structure of your performance task. So, evaluating the trig function, example 1. The question is simply tangent of 330 degrees. So the rotation is 330 degrees. So down here I gave us some bullet points to kind of think through. The first thing we're going to do is draw the rotation. So we need to know from day 2's video, where is 330 degrees? 330 degrees is going to be in quadrant 4. And that's because the pole at the bottom, the south pole, is 270, and then the pole on the right is 360. So then we need to find the reference angle, just like we did in day 2's video. Well, the reference angle, remember, requires that we subtract the rotation to the nearest x-axis pole. So I'm going to take 330 degrees and subtract that from 360 degrees, which is the nearest x-axis pole. So 360 minus 330, and that gets you 30 degrees. Oh, where have I seen 30 degrees before? That's my special right triangles. So now I can label my sides of this triangle. But because we're in quadrant 4, we need to pay attention to positive and negatives. Across from 30 will be a 1, but because we're in quadrant 4, it's negative 1. It's going down. The hypotenuse will be positive 2. The hypotenuse is a radius. It's always positive. Process of elimination makes the x square root of 3. And that is indeed positive. Cool, so we finished bullet point 3. Label the triangle sides. We did positive, negative. And now we're going to answer the actual question. So tangent of 330 degrees, well, what sides do we look at for tangent? We look at opposite over adjacent, or we look at y divided by x. Here's your y side in -1. There's your x side in root 3. Set those up. You have a -1 on top over square root of 3, which you need to rationalize that answer. So you multiply by root 3 over root 3, and you get a final answer of negative square root of 3 on top, all divided by 3. And if you think about it, this last bullet point, check the positive and negative. In Q4, cosine is positive, ASTC. Anything else besides cosine in quadrant 4 should be negative. So when I ask you about tangent, did I get a negative answer? I did. Boom, I'm good. If you mess up positive and negative signs a lot, that's going to be the difference between, say a 2.0 and a 3.0 for this standard. So make sure you're using ASTC to check your answers. Even if you get all the way to the end and you're like, oh, ASTC, I know this answer better be negative, and you slap a negative sign on, as long as you explain that to me, perfect. That's what I want to see. 225 degrees. We need to find out what quadrant 225 degrees is in. That is in quadrant 3, because that is between 270 and 180. And I need to find my reference angle. My reference angle is from the rotation 225 back to the nearest x-axis pole of 180. Hey, 45 degrees. So this is also a special right triangle as well. So make sure that we follow the special right triangle for a 45, 45, 90 triangle. Across from the 45s are ones, but because we are in quadrant 3, both x and y are negative, and the hypotenuse in a 45, 45 is root 2. We've got all the sides labeled. Now we just need to answer the question. We need to evaluate the trig function. If I gave you the rotation, what are the sides? So sine, opposite over hypotenuse, or more commonly referred to as y over r. My y value is right here in -1, and my radius is root 2. Am I done? Do I need to rationalize this? I do, because I can't have a square root on the bottom. So square root of 2 over square root of 2. Boom. And if I think about ASTC in Q3, that's where tan is positive. So since my question asked me sine, my answer should be negative. Boom, done. And our final question for the lesson. This is kind of what your performance task is. You are obviously not filling in every single one of these boxes. You are only focusing on the boxes that matter for your quadrant of the rotation of 120 degrees. So hopefully you know that 120 degrees falls in quadrant 2. So we are going to focus our attention on those yellow orangish boxes in quadrant number 2. And what is the reference angle? What is theta? Well, if my pole is 180 and my rotation is 120, the difference between those, 180 minus 120, is 60. Boom. Now, so you're going to type in 60 degrees into that little spot, and then you're going to fill in the 3 orange boxes for your x, y, and r sides, not necessarily in that order. Across from 60, this y side, that is square root of 3. Is it positive or negative? Y is going up, so it's positive. The hypotenuse is 2, and process of elimination makes this 1, but it's negative. And so this is my x, this is my y, this is my r. And now it's time to answer the question, what cosine of 120 is. I know cosine is x divided by r, so my x number is -1, and my r is 2. And really, that's it. That's my answer, -1/2. So you'd want to be able to explain what you did and why you did. Your explanations matter to me. Make sure things are positive and negative are aligned correctly. If you haven't seen this diagram, it might help you. The idea is that all of these x's are the left and rights, the y's are the up and downs in these triangles, and the radius is always the slant. Okay? And that concludes our day 3 video. There is some practice problems that you're going to definitely want to do today. We are doing a pair deck the next day, and then we'll have our performance task. Thanks for watching.